without further ado, I'd like to welcome to stage Dr. Wolfgang Schleifenbaum, the head of the production area hydrogen at Bosch Manufacturing-Solutions. Welcome, Wolfgang. And you will talk about water purification as a key enabler for green hydrogen production. Looking forward to your presentation and the short discussion afterwards.
Thank you. Water and energy are two of our fundamental resources on the planet. Can we utilize the one without managing the other? In nature's water cycle, the sunshine evaporates water from the Earth's surface, turning it into clouds and storing the energy there, which is then released during condensation. We can look at this. Well, here are no windows, but in Berlin today it rains. When we move into the green energy transition, we again use sunshine, solar energy, and other renewables to split water molecules into hydrogen and oxygen, storing vast amounts of green energy there in those gases in order to release them in the processes that use the hydrogen. And we all want to achieve so much, these vast amounts of energy, but it must be clear that we need to provide the water to do so. Ladies and gentlemen, welcome to my talk on water purification technologies. The electrolysis projects that start throughout the world, they are in industrialized areas where we have tap water. They are in desert areas and offshore regions because the renewable energies are abundant there. And there you find saline water. All these regions have in common the ultra-pure water needed for an electrolyzer to process is just not there. So every electrolyzer that we set up will have as an accompanying partner a water purification device. And this device has to make sure that the water the electrolyzer processes is ultra pure in order not to jeopardize its lifetime and in order to keep a reasonable levelized cost of hydrogen. The purity is measured in electrical conductivity. Ultra pure means very low electrical conductivity. Depending on the electrolyzer technology you choose, it's 0.1 microsiemens per centimeter. And the water that you use, for example, saline water, has conductivities up to 50,000 microsiemens per centimeter. That means a lot to do for this water purifier. The amounts of water that are being used, you see on the slide, for a kilogram of hydrogen, we need 9 kilograms of water. Just to get you an idea, in this bottle is some water. We could turn this, after purification, into green hydrogen, and that would store about a kilowatt hour of energy. Now, you know, we're not talking kilowatt hours here, we're not talking gigawatt, we're talking terawatt hours, so we need vast amounts of energy. It sums up for the net zero scenario to about 4 cubic kilometers of water per year. That sounds a lot, and it is a lot. But again, if you look at the different industries using water, chemical industry, agriculture, the water needed for globally for green hydrogen production is just 1.8% of the water consumption of humanity today. So it's small. Nevertheless, the message must be, in those areas where we make the electrolysis, we still need the water. So if you go to a desert area and you have no water at all there, of course you have to make sure it's there. So water availability is a very important topic, and while there are existing technologies for water purification, this is a new use case. This use case that we look at for water purification couples with the electrolyzer in sometimes remote locations. It has very tough physical boundary conditions the technology has to be able to cope with. One thing is intermittency. Start, stop, and behavior of the energy, unexpected. This is something the technology needs to be able to handle. The second thing is serviceability. So we need in remote location a technology that is very robust and needs low maintenance. Question is, can the water purifier guarantee that? And the third thing is sustainability. So green hydrogen approach must also assure that in the water purification there's no harm to the nature, and we don't take away water from other uses. So those 3 points are important for a water purification device, and at Bosch we made up our minds what can be a good technology, and we are entering into the market with a solution I'm showing here on the screen. This solution is containerized, and it combines a mechanical vapor compression distillation with an electrodeionization unit. You can imagine this is a container. You input water, this can be seawater, you get out ultra pure water to process for the electrolyzer, be it PEM, be it alkaline or other electrolysis technologies. We have sized this water purifier to supply the process water for electrolysis up to 15 megawatts of capacity. And it weighs about 10 tons. It takes in seawater of 50,000 microsiemens per centimeter, and the output is ultra pure. One thing that you may wonder if you hear distillation is evaporation and condensation. That takes a lot of energy. However, we have implemented in our device recuperation of this latent heat needed for evaporation, and this results in the fact that we need a very small fraction of the energy of the entire system coupled with the electrolyzer. To produce a kilogram of hydrogen, an electrolyzer needs around about 50-60 kilowatt hours. The water purification coupled to that electrolyzer needs only up to 0.2 kilowatt hours. This means we have really marginal amount of energy that is needed here for the water purification. And rather than trying to save any energy there, we advise to focus for water purification on its robustness, so that you make sure you have no downtime ever of your electrolysis system due to any failure that you might have in the water purification. We want to point out some features of water purification technology for hydrogen production that we consider are the most important ones. The one is that has to do with the intermittency of renewable energies. It must be dynamic. So any changes in the load, the device must be able to follow within seconds or up to a minute. The second thing is it must be robust. Some of our customers are asking to apply the device in desert areas with strong winds or outside in the offshore area. We have to make sure that it has always the constant ultra pure water quality, and it has very low maintenance. And we aim at once per year to plan a maintenance, so in order to avoid any operation cost. And the third thing is sustainability. So when you have water purification, you always have an output of the ultra pure water, and you have the brine, which needs to be disposed. And we can minimize this brine disposal with our technology. This is linked to the fact that it's a distillation technology, and we can dial up the water efficiency up to nearly 100%. And the second thing is that related to sustainability, we don't want to add any chemicals to the process. If you look at this one example, and this is a very innovative, exciting example, and you know it, the decentralized offshore hydrogen production, it becomes immediately clear that here, where you turn seawater outside on the ocean into ultra-pure water to be processed by an electrolyzer right there at the wind turbine, you do not want to add any chemical to the process. A state-of-the-art, membrane-based water purification device does need lots of chemicals. We want to make sure by adding no chemicals, this is a sustainable approach. I mean, with green hydrogen, we're all here because we want to be able in some decades to turn to our grandchildren and say, back in the 20s, we turned this climate change thing around and we introduced green hydrogen, but we don't want our grandchildren to come back to us and ask them, why didn't you care about the quality of the water? So no chemicals to be processed here, maximally robust and low maintenance in order to be able to have a maximum uptime with this green hydrogen production scenario. So let me point out what we do at Bosch Manufacturing Solutions. What I just presented is a water purification device that we are entering the market with. We also have at Bosch Manufacturing Solutions the integration of electrolysis systems for specialized applications, including H2 testing. We also have production equipment and testing solutions for hydrogen injection components. We have them for fuel cells, for the mobility sector, and also for the stationary energy sector. I welcome you to join us in our booth number 1. My colleagues and myself will be happy to talk to you about those fields. Thank you very much. Looking forward to questions.
Here they come. Thank you, Wolfgang. One of the questions is what happens to the residues of the purification process? So, for example, the brine.
Right. So, of course, when you have input water, and be it in that example, it's seawater that I just showed, you have the ultra-pure water, but then you have a concentrate of the salts, and you have to dispose of it. What's important there is to comply with regulations. Yeah, right? And the regulations, they may forbid that you add any chemicals that you need for the process into the environment. And so it's always an advantage to be able to say that in the process there are no added chemicals. Mm-hmm. What really happens then in practice is you dilute this concentrate again and then dispose it off in the environment.
Into the sea.
Right. In this example and in other examples into the sewage system. Mm-hmm.
Okay. How much water is lost during your process?
Right. Yeah, that very much depends, you must say. So in this setup that we have now, we have a 50% water efficiency, but that's really by choice. We can concentrate up the water quite high, and if needed, we can actually concentrate it up to nearly 100%. There's technologies we could add to this. This is the so-called zero liquid discharge, which is an innovative technology we could add to it technically. But this is possible. But right now, at the moment, we have 50-50. So you give me 2 liters, 1 liter for the electrolyzer, and 1 is disposed of.
Okay, good. Is it also possible to use the water purification system to make drinkable fresh water out of salt water?
Generally, yes. Yeah. So the distillate water that we produce, it can be remineralized and then be consumed as drinking water. And there are ways to do this. And I would consider this really as a chance, as a dual use case to produce water for green hydrogen production, but also for the people that work right there. I mean, we're looking at producing hydrogen in areas which are water scarce, and this is a possible dual use case.
Okay, yeah, very good. Could you elaborate again on how the energy required for the distillation is very low? You said normally you would need a lot of energy and then Could you make your point again why it is low in
Sure,
your
yeah. Okay. Yeah, so the distillation of energy, of water, sorry, is usually energy intensive. What we do is we evaporate water that needs lots of energy. We have then a steam compressor that raises the pressure on a higher level. This also means that the condensation that then happens is on an elevated temperature. And that means condensation happens at a hotter temperature than the evaporation. Then you can use heat exchange principles to win back that energy. That's the recuperation I mentioned. And this ends up in the end to be an energy efficient water purification method. We must say it's more energy consuming than a cold membrane-based technology, but like I mentioned before, we are still in a range that the energy consumption for water purification is tiny compared to the electrolyzer.
The time is out, running out. There is one question. I mean, this is a mega question. You see, would you like to make any short, specific comment on that, and then ask maybe the person who has asked that question to join you tonight to get into a longer discussion? Is there any particular point you would like to highlight on the question? How you let's say, with your applications also intend to stay competitive versus other competitors, for example, Chinese competitors here?
So we believe we will have with this technology especially for the use cases in remote locations, or a competitive good solution with a good product market fit. That doesn't matter if we're in China or Europe or anywhere. So we're going worldwide. And yes, I follow your recommendation. Please, let's continue this discussion in the booth.
Great. Thank you very much, Wolfgang.
Thank you.